Okay, good afternoon. This is another mixture problem that I would like to share with you. Special shout out to my friend, my former colleague in the MC Science High School, Sir Louis J. Twiza. Thank you for the heads up, Brad. Thank you for the friendly reminder and the heads up that I need to use the right term. Okay, let's proceed. Suppose you work in a lab. You need a 15% acid solution for a certain test, but your supplier only ships a 10% solution and a 30% solution. Rather than pay the hefty surcharge to have the supplier make a 15% solution, you decide to mix 10% solution with 30% solution to make your own 15% solution. So, as you can say you are a chemist or whatever is your work, basta you work in a lab, and then you need an acid solution which is 15% acid solution that you need in a test. However, your supplier ships you with a 10% solution and a 30% solution. And take note that what you need is a 15% acid solution. So, instead of paying the hefty surcharge to your supplier, since you know something about algebra, you use now your skill and your knowledge in algebra, you decide to create your own solution by mixing the 10% solution with the 30% solution. Okay. Another thing that must be considered is that you need 10 liters of the 15% acid solution. Okay. How many liters of 10% solution and 30% solution should you use? Okay. So again, the use of tables in solving mixture problems will be a very big help. Actually, this may be dispensed with, especially if you are already well versed in solving mixture problems. When I was studying in college, I really found this type of problem a challenge to me that time, until I was introduced to the use of tables. Then that's the time I started to appreciate the lesson on mixture problems. Okay, as beginners or as starters, you may make use of mixture problems to aid you in coming up with the correct answer. So, the first column is normally the solution. There are two solutions, namely solution A and solution B. Solution A is 10% solution. And then solution B is 30% solution. Mixing solution A and solution B will make you obtain the desired mixture. Okay. Your desired mixture should be a 15% acid solution. This second column should be under the heading concentration. Okay. Yesterday, I actually used the term acidity. Now, somebody told me that acidity might not be the correct term. It should be concentration. Correct me if I'm wrong. I stand corrected if this is not really the correct term. Okay. But in as much as algebra is concerned, this is how you're going to construct the table for you to arrive to the correct answer. So regardless if the correct term is concentration or acidity, this should be the procedure. Next column would be the amount of concentration or the amount of acidity, which will be in liters. Okay. Your desired mixture of 15% acid solution should be 10 liters in all. Of the 10 liters, how much of it is solution A? That you don't know. That's why you assign it with the variable x. Of the 10 liter solution that you desire, how much of it is solution B? That you also don't know. Hence, you assign it with 10 minus x. But since this is in application to the lesson on systems of linear equations in two variables, you make use of two variables. So after using x, you may then use the variable y. But actually, that variable y is still consistent with the concept that, say, if the sum of two numbers is 10 and the first number is x, then the second number must be 10 minus x. Correct? Since x plus y is equal to 10, x plus y is equal to 10, then y should be 10 minus x. Okay, what I'm just trying to say is that in this particular type of problem, you may use one variable or you may use two variables. Again, since this is in application to the lesson systems of linear equations in two variables, you make use of two variables. Okay. It actually doesn't matter whether you use one variable or two variables, for as long as you do not violate any rule in algebra, then I think we will agree in one thing in the end, that the correct answer should be this one. Regardless if you use the one variable or your classmate uses two variables. Okay. Next, last column would be the amount of concentration or the amount of acidity. That is obtained by simply multiplying the concentration or the acidity by the amount, which is expressed in liters. Hence, for solution A, the amount of concentration would be 0.10 x. While for solution B, that would be 0.30 y. Now, don't get me wrong. 0.10 x can also be written as 0.1 x. 0.30 y can also be written as 0.3 y. Okay. So why am I writing it with two decimal places? That is to be consistent with the product of the desired mixture with the amount, which is 10. So that's 0.15 times 10. Do you follow? Then we set up the second equation. Oh, by the way, x plus y is equal to 10 is the first equation. Okay. What does the first equation mean? Of the 10 liter desired mixture of 15% acid solution, how much of it is solution A? You don't know that. That's why you assign it with variable x. How much of it is solution B? You also don't know that. That's why you assign it with variable y. Then, solving for y, that's y is equal to 10 minus x. For solution number For equation number 2, for the second equation, you just simply take the sum of the amount of concentration for solution A and solution B, and then the desired mixture will be the sum of the two quantities. So you have 0.10x plus 0.30y is equal to 0.15 times 10. Okay. Most of the students that I had before, they don't really like, or they don't really love doing things in algebra when decimals are involved. And there's no problem with that. So to get rid of decimals, you simply multiply the entire equation by 100. Why 100? Because there are two decimal places as numerical coefficients of x and y, and also the number that is to be multiplied by 10. So it's better, it's preferable that you multiply after, you multiply the numbers that are found on the right side of the equation right after you multiply 100 to both sides of the equation. Okay, so multiplying 100 to both sides of the equation will result to 10x plus 30y is equal to 15 times 10, which is 150. So multiplying 100 to both sides of the equation will actually move the decimal place of each decimal number twice from left to right. Okay, I think that is very elementary and that doesn't need any further explanation. What do you notice with 10x plus 30y is equal to 150? So all the numbers, the numerical coefficient of x, which is 10, the numerical coefficient of y, which is 30, and the constant term, which is found on the right side of the equation, are all divisible by 10. So for you to get rid, or for you to do away with very large numbers or computing very large numbers, you may reduce the second equation by dividing 10 to both sides of the equation. So you have x plus 3y is equal to 15. Substitute the value of the variable y found in equation number 1. So you have x plus 3 times the quantity of 10 minus x is equal to 15. Distribute 3 to the quantity of 10 minus x. X plus 30 minus 3x is equal to 15. Combine like terms and subtract 30 to both sides of the equation. Negative 2x is equal to negative 15. Negative 15 is obtained by subtracting 15 by 30. Right after you subtract 30 to both sides of the equation. Again, it's okay to use the term transpose, but actually the term transposition does not really exist. Some mathematics teachers, including those who have influenced me, do not really believe the term transposition. It should be in accordance with the addition property of equality. So this is just like adding negative 30, which is the opposite of 30. That's adding negative 30 to both sides of the equation, or it can be subtracting 30 to both sides of the equation. Now, since you have negative 2x, which is equal to negative 15, this time you will have to divide negative 2 to both sides of the equation. So dividing negative 2 to both sides of the equation will result to x, which is equal to 7.5. 7.5 what? 7.5 liters. Okay. There are some science teachers that I know that they are very particular in the use of the unit of measurement, that according to them, whenever you do a solution, the unit of measurement must be written all throughout the solution. Kaning procedure. However, since this is algebra and putting the unit of measurement as early as diri nga step will somehow confuse some students, because we all know that this is a letter in the alphabet, and this can represent an unknown, which is not, di ba? So better to put the unit of measurement after na. Okay. So x is equal to 7.5 liters. Now if x is equal to 7.5 liters, y is 2.5 liters. Y, which is 2.5 liters, is actually obtained by subtracting 10 by 7.5. Since y is equal to 10 minus x. Okay. What does this mean? Okay, what do these values mean? Going back. Diba, you work in a lab, you need a 15% acid solution for a certain test. However, on hand, you have a 10% solution and a 30% solution. Dili pwede nga gamiton nimo ang 10% solution in replacement or to substitute the 15% solution. Dili pud pwede nga you will use the 30% solution to replace the 15% solution. However, what you can do is to do a mixture to make solution A of 10% acid solution and solution B of 30% acid solution to come up with your desired mixture of 15% acid solution. Tapos, ang imong kinahanglan should be 10 liters. So, how much of solution A will you add and how much of solution B will you add to create the mixture? So, based on what we have obtained, you need 7.5 liters of solution A and 2.5 liters of solution B of 10% and 30% solution or concentration respectively to come up with a 10 liter 15% acid solution. I hope that helps. Thank you.